David Norman. I'm with Discover Battery, and I'm here today just outside Redding, California with Jason Andrade, West Coast Sustainables. We're in his workshop. If it's not clear and apparent to you, it's one of the coolest workshops you'll ever see. Today we're going to do basically some manipulation of his existing home system. Jason, maybe you can walk us through what we're going to do today.
Yeah, so this is my off-grid house. My family and I, we've been here for about 5 years, and the system that we're going to work on today is the system that powers our off-grid wood shop and our maker lab where I make a lot of stuff for my business. Today's project is really going to be taking an inverter system that I got from a customer. It's all kind of repurposed stuff. That's why it's kind of an older vintage. These are some Outback nanocarbon batteries that I got off another project. And so what we're going to do is we're going to remove these batteries, and I built a new back plate, and we're going to bolt that to the wall, and we're going to install 3 of the Discover AES 6.65 batteries. Cool. And get this thing running off lithium iron.
So this is what, 600 amp hours lead acid, flat plate. We're going to take this off and basically add 390 amp hours of lithium. Mm-hmm. Wall mounted though, rather than floor mounted.
Correct.
Stand. And anything changes to the electrical side and the AC side?
No, we'll be able to leave all this as it is. This is a DC coupled system. So all we really need to do is just do a quick upgrade, just to switching out the batteries and putting our new back plate on and mounting them on the wall. It should be pretty easy.
Cool, cool. I would suggest the least time-consuming part of it will be updating the settings and things when we plug into the Zen bus network, so we'll get a chance to see that too.
Awesome. All right, let's get to it. Okay, so this is just a rack that I built to house these batteries. They typically would go in the Outback IBR3, but I want something a little more low profile. Yeah. So to really safely unhook these, all we're really going to do is just turn off our main DC breakers in our PDP, and right now we're pretty safe to unhook these things. Okay, now that we got the battery rack, the old one, removed and all the batteries out of here, next we're going to remove the nipples, and we're going to adjust our new backer to fit underneath the inverters, and then we're going to start installing the back plates to get ready to hang the batteries. Just run it right to the bottom of the OSB on this one. Okay. And then that gives us an idea where we want to be right there. Buddy. So we're getting ready to put about 600 pounds worth of batteries on this wall. So one of the things that I want to do is really, I have 2 objectives. One is I want something that's going to be really solid for the batteries to mount to. So we are using a piece of 3/4 inch plywood, and I wanted to take some time to make it look nice. So I sanded down this maple ply, put some tung oil on it, and made a nice trim to go around it, which is also going to allow me to attach a shroud to it later to protect the battery terminals and also protect the batteries from any kind of damage while I'm working in here. All right, so what I'm going to do is I'm just going to use this countersink bit to do some pre-drill just to make it easy to start our bolts. And then I'm going to pre-start them so that way it makes it easy to get it up on the wall. Beautiful, that'll get us close enough. I like that, looks good. All right, so we did it. We got the old batteries removed. We mounted the new back board, and we actually mounted our plates on to try to get a mock-up of how everything was gonna fit. Now that we've done with that, we can put the trim ring on, and we can really start assembling everything and running our cables for the batteries. Yeah.
So just so you people at home understand this, it's not normal to do this trim ring. Jason's a bit of a exception in this regard. He actually prefabbed a steel casing that he's going to use as a shroud for this site afterwards, so we can do some cool things with lighting and stuff after the fact. We won't cover it today, but it's for future proofing basically, and allows us something to work off of afterward.
I think with the back plate and hitting the studs, we're going to have good security that we're going to be able to stick to the wall pretty good. Yeah,
yeah. I mean, essentially, you're talking about 3 of me or 3 of you on this wall, right? At 600 pounds. So it's better to be safe than sorry.
Awesome. All right, let's do it.
Cool.
All right, we should just line up the X's, and everything should go on.
Okay. So we just want this flush mount to be.
Yep, exactly. No. We're going to go right justify just like that. And then we're going to put the other one lined up with this one, so that way when I add a 4th, all I got to do is put it in right there. Does that make sense, kind of?
Totally.
Next plate. I'm going to say that looks pretty good. I think if we go right here, so fine. So if that goes there, yeah, dude, look at that. Because that's gonna stop right at the top.
Yeah.
That is right there. That gives us 6 inches of clearance in between the two, don't you think?
Yeah.
Okay, now step back and just check your laser. Okay, awesome.
Okay, so we're back from our lunch break, and we've basically mocked up where the mounting bracket's going to hang. You know, again, we've got them affixed solidly to studs, at least 2 points on the outsides. They are heavy batteries when they're 90 kilos a piece. We've also left some spacing here for wire runs and conduit, and essentially we've got 3 batteries stacked at present. That's what we're going to install today, but I'm planning for a 4th battery in the future.
Well, one of the things to really put in the thought mix here is we were really going back and forth whether we were going to put all the batteries face down for the cable runs, or whether we wanted to alternate one. But with leaving room for this 4th battery that we're going to add later, it's going to be easy to bring down independent feeds for each parallel connection. And then one of the other cool things that we're going to be able to do also is there's a spot up here that we can run a conduit down to also feed all of our comms cables to keep that nice and tidy also.
Okay, so moment of truth here. Essentially, we've got the backer plates on. What we're going to be doing is just lifting and mounting in place. Just because you can't see the back end of the battery, essentially there are these steel extrusions that are meant for structural strength. They also serve as the mounting points for the mounting bracket. We essentially just match these up, lie these in here, then it's load bearing, and all we have to do is tack on the tops of the batteries to the backer board, which is again super wise install because it makes it easy for us to do this mount afterward, but we'll tack on the top bolt holes and fix them to there, and then it's a mounted battery.
The other thing we decided to do too to save stress on our back was to raise the batteries so that we're not lifting from the ground, so that we can minimize our lift point. So we're going to see if this works.
Cool.
All right, so we did it. We got the batteries mounted. We had to overcome the weight issue, but with our 2x4 design, I think it went pretty smooth.
Yeah, that was actually a slick head.
Yeah, so all we have left to do now to really get this thing up and running is, I have it prepped with some chase nipples, and we're gonna do some unistrut to support the cables, put a conduit in for our communication. Basically, we're gonna use the right chase nipple to go to our top batteries, left to the bottom. We decided, you know, looking at different ways to orientate these, we decided to run them all facing down. So that way, when I add the 4th battery, all I have to do is extend the cable over, make a jumper, and it's going to be very easy for me to add this extra little capacity later. So what do you think about the communications?
Yeah, so once it's done electrically, what we'll do is we'll hook it up and run it in basically what we call open loop mode, and that's where the batteries are acting as lead acid replacement. We'll just compare them. I'll go through the setup on the SCP, set the voltage parameters and the like that we would do for this custom battery setting. We can see how it runs then, do some trials on it, run some loads on it and the like. And then what we could do afterwards, we'll just connect the network connections to this. So we'll interconnect the batteries so they're talking together over common AE bus. That's the communication protocol we have to do our paralleling. And then what we'll do is connect the external network and network the batteries to the XW system over the ZAN bus protocol, and terminate the network properly, and then see the difference in performance on here. You'll also see, it'll be pretty clear and evident too, you'll get the auto-populated settings pushed up to here, and then we'll let it try and do a recharge cycle networked so that we can see the difference in the charge profile as this starts to drive instead of just being a passive fixed setting.
Will the SCP see the batteries as a device?
Yeah, so in terms of the SCP, your Connect's Insight, if you log directly into the COM box itself, what these batteries will replace is an existing Schneider Electric piece of equipment, which is their battery monitor. I think it's called Batmon is the actual literal name of it, the device on there. But it replaces and supplants all the information that you'd typically get from their external battery monitor that's designed to do some of the fancy data logging and the like that we have built into the BMS of this product for lead acid batteries. Right, so it's just going to replace that set of parameters and appear as that device on the network.
Okay.
Yeah.
Well, I got all of our battery stuff set up. Let's build some cables.
Cool.
Off there, so we start with a nice clean edge. Easy peasy. So we got all of the cables made. We put our crimped ends on, both for our negative bus bar and for our positive. It was a bit tight through here. This is a pretty open panel to do, but expect to have to weave through some existing stuff to get it placed in here. But now that these are all put in, we can move on down and we can hook up the rest of our cables on our batteries. All right, so our next step is we're gonna use some unistrut and some clamps that I picked up from my local Reading fasteners, and we're gonna use those to affix the cables to some unistrut to the wall to keep everything nice and isolated. And what's really nice about these unistrut clamps is they have an isolated rubber protector that's gonna keep everything safe and protected from the metal. Beautiful. Okay, so this is actually UL listed Cobra wire. It's 105C, it's 4/0 cable. One of the things we really like to do is we always like to use the proper cabling for all these projects. You want to make sure that you're following all the codes all the time when doing these types of battery projects.
Conduit off.
Okay, now that we have our strain reliefs in, our unistrut with our cable glands, the next thing we're looking for is the proper flow pattern for the battery cables. We have the battery lugs right here, which have to be 90-degree opposed. So we know that our battery cable needs to feed up from the left-hand side, both for the negative on the first battery and for the positive on the far battery. Both cables need to have a similar feed point coming from the outsides. And one of the things I really like about using these batteries is I'm really able to wire them similar to a lead acid battery, to where I can parallel these batteries and jump them. I don't have to have an independent cable run for every battery. I can just run a home run to the main connection point and then parallel them off that. Wouldn't it be jacked up if you cut my finger off right now? It really worked out nice that we were able to reuse some of our original cables. We just had to add one extra parallel section to hook up the bottom batteries, but this is reusing what we already had here. What do you think? Now that we got our home run cables done, we're gonna work on our parallels. One of the nice things about the bracketry that you get from Discover Battery, it places the batteries the same distance apart every time. This is gonna allow for rapid duplication of parallel battery connections if you're gonna have more than two. So you're gonna be able to figure your distance from terminal to terminal and mass duplicate these cables even before going out to the job site. We're only gonna have to make two for this job, but it should be pretty easy. Now that we got the home run cables ran, we've removed the safety plugs off of the batteries. One of my favorite things about the lithium iron phosphates is the fact that they ship and you get to hook them up with no voltage. The battery has an on-off switch that powers up the BMS, which actually opens up power to the battery. Is that correct?
Yeah, the solid state relay opens up.
Yeah. So safety-wise, this is a very great battery for beginner people to work with, and I like that. So we have 0 voltage with the battery turned off. Go ahead. And now you can see that the battery is at 52.7 volts, ready to go. All right, that was our last home run battery cable that we had to do. Next, all I gotta do is do some zip ties to support the cables up. We left some space right here to move the cable over later to accommodate for the 4th battery. After this, we're gonna fire up the system and we're gonna do the commissioning procedure for the lead acid replacement function, and then we'll show you the difference between that and the communicative system.
So Jason's just in the other room building up some Cat 5 cables so we can connect the batteries in a closed loop scenario afterward. While he's doing that, it's a good chance to demo for you how these batteries work as a lead acid replacement mode. We call that open loop. In other words, not connected by anything other than the battery terminals. The simple setup on these, again, this is Xantrex inverters, so they're pre-Schneider XW+. which would give you a good idea that if you were setting up a Magnum system or an Outback system or Morningstar charge controllers or Midnight Classics, whatever you want on your power electronics side, you don't have to have closed loops comms to make that happen and make the batteries really work for you. I went through the system parameters here, changed the charge profile settings, bulk setting at 54.4 volts under a custom profile, absorption setting 54.4 volts, and I left it as a 2-stage charge on this one. Absorb time I did reduce, and I disabled the equalize. Okay, that's just good practice. When you do closed loop install, it takes care of all the settings for you. So in an open loop install, you have to do this manually yourself. All the directions are in the box that comes with the battery. It's super simple. Now to demonstrate to you just that they do work in that mode, and again, the load I'm going to put on is a 2-horse air cleaner. It'll give you a pretty good inductive inrush, and then it'll power down afterward. It's basically a demonstration. It nowhere near pushes the boundaries of what the batteries can actually do or what the inverters can do. If you keep your eye here, okay, so at startup there, it was 275 amps DC pulled out of the batteries. That's essentially the continuous rating of 2 of them. It didn't stress them into going into inrush mode at all. Anyway, there's your quick demonstration of the battery setup with closed loop or open loop communications, and next up is the closed loop.
All right, we did it. We got all the battery cables done. We've now moved on to the network. We have 2 different networks that we have to install, one for the battery communication, and then one for the ZAN bus. And we're gonna start wiring up those now. We pre-made some cables. Is there anything you wanna add?
General practice, good practice when you're dealing with a CAN network. Any CAN network has to be terminated on the terminus ends. So one of the things we've done, just as a reminder for that, so we've taken the Y splitters. Basically what we designated the batteries for is 1, 2, 3, or 1, 2, 3, however you want to say it, but this will be the one that's being daisy chained in between. The 2 batteries on the end, we pre-populated the network terminators. A device like this goes in and it just basically tells the CAN network to stop looking, and it's finished, so that there's no network communication errors. That's pretty much the only thing you can do to screw this aspect of the install up. So with that said, and we're just going to go ahead and connect the pre-done wires. Just as a note, Jason Andrade kind of guy, he actually color codes the different network terminators. So the white will be the internal AE bus. We're going to connect those on COM 1. And once we do that, the batteries are interconnected as far as any outside network would know. And then what we'll do is we'll finish up with the ZAN bus connection and go through the settings. And
for safety, we have the batteries off while we're doing it.
Yeah, yeah.
All right, the network is all terminated. We have COM 1 completely wired. The AE network is ready to go. Now we're gonna move on to the ZAN bus wiring, and we're all done and ready to turn the system on. Okay, so we have the AE COM 1 done. Our next cable to do for the comms is really just a simple one, the simplest one that we're gonna do. It's just gonna be connecting the ZAN bus to the leading inverter. We chose to go to inverter 1, but you can go to any one, is that correct?
Yeah, yeah. Once the batteries are interconnected on CAN, you can pick any one of them to choose your quote unquote home run to the ZAN bus network. In this particular case, we removed the terminator from the MPPT charge controller and we ran it from there. So this, again, just best practices, right? We terminated the endpoint right off the bat so we couldn't miss it and forget it. And leaving that here now. So the last termination, it will be daisy chained from the MPPT, run underneath. Jason's going to go over the conduit placement and this kind of stuff, but we'll connect it here to COM 2, which is the ZAN bus network. And essentially at that point in time, we're done. We'll energize the system. It'll recognize the battery bank. Now it's 390 amp hour block. It'll be pushing all its own custom profile and settings up to the inverter to set all the parameters. And you'll see the representation of that here under the device titled Batmon.
Was there a lot of settings to change to do that? Absolutely not.
No. As soon as you connect to a ZAN bus network, the BMS inside the battery pushes the network settings up and populates that for you.
That really simplifies that.
Well, it takes out a lot of user error.
Yes.
It takes out a lot of time, and if you only have an SCP, this isn't the best, graphic user interface. So it's hard to thumb through. It's like an old cell phone. With a COM box, admittedly, it's a lot easier. And frankly, if you're doing a bunch of these systems at a cookie cutter, you can pre-populate a USB thumb drive with all your settings and do it manually that way. But this will do it. Add another battery when you add your fourth on. It'll automatically, add that additional 130 amp hours to the parameters in the battery bank size here.
Okay, great.
Yeah.
So what I think we're going to do next is I already bent a piece of 3/4 inch EMT conduit. It's what the existing hole was coming out of the PDP. We're just going to slide it up out of our Cat 5 for our ZAN bus and then connect it up and see what we got.
Yeah, I think after that, the first thing we should do is probably turn your gen set on and go through the charge cycle so we can see how this is dynamically controlling that function.
Sounds great.
Cool.
All right, there we go. How'd we do?
Looks amazing. Looks amazing. Got to tell you, some of the attention to detail that you don't see in every install. Now, granted, I'm used to seeing these things on the floor in the lab where the guys are doing quick connects and the like, but color coded with heat shrink on the 2 different networks. So you got AE bus in white, you've got the ZAN bus in with black heat shrink, right? All of it's tucked back instead of looping over as a big tripping hazard or a snag hazard and the like. It looks beautiful. You did beautiful work.
Thank you. I think we're pretty set up to build the shroud, do some lighting with our state of charge, and have some fun when Brennan comes down. Yeah,
no, exactly. So one note for you here, code compliance wise, I mean, you'll see typically these terminals have got to be covered and the like. We do have covers for those, but in this case, he's building a shroud over the top that's going to cover this. We're going to do some lighting effects.
It's going to have plexiglass so that we can see the batteries and really see what's going on. If any of you really follow some of the stuff I do, I really like to keep it fun and lots of lighting. So this will have a metal cover with plexiglass across the front of it. We're also, as I play with my wood shop more, I have a lot of air filtration, but I'm seeing I do have dust. So I want to try to keep the dust off the battery. So that's also really going to be integrated into the whole thing, kind of a plexiglass dust lighting enclosure.
Yeah, they are flat leveled, so it's a dust collector.
Yeah, it's going to sit here.
Yeah.
So.
Yeah. I guess the next thing to do, we'll just power it up and we'll kick the generator on and just go through the charging cycles.
Sounds great.
Perfect.
Let's do it. How are we looking over there?
Well, it's basically set up right now. It's recognizing the batteries as being lithium batteries on the custom profile because it's connected on ZAN bus. It's showing me a state of charge if I exit here of 3/4 full. Again, we've just been putting sporadic loads on it today, so it's sweet. But I'm interested to see when we actually turn the gen set on and engage the gen set, go through the charge routine. Make sure, because we never touch the voltage settings and things. We'll watch it dynamically control that. That'll be pretty cool to watch.
Well, I got the generator running right now.
Nice.
While that thing warms up, let's just, I would like just to say that I think it turned out great. All in all, that was a pretty simple upgrade. I learned a few things. I understand the communications. That's really a pretty easy flow for what we had to do. They're darn heavy, but we managed to do it. It's definitely a 2-guy job. Oh yeah, dude, it's never hit that much. Dude, that's insane, huh? I travel a lot, and so I have the ability now to remotely monitor my batteries. Well, before I could see what my voltage is doing, I can really see the health of my system, and I think that that's a big benefit for what I have going on and being able to make sure that my family has power because I am the power company. Being able to see that they're okay while I'm traveling. I mean, that's a big benefit, I think, to what we have going on.
Yeah. Additionally, I mean, even doing things like you talked about before, you can now that you have this reporting up to your monitoring devices through CommBox and Insight, right? You can do a side-by-side comparisons to the system. You can do tweaks on the go. Firmware updates as we release some of these kind of things as well. So.
Well, once we get the next battery in, and we're at, I think, 26 kilowatt hours on this system, I'm really going to have a pretty robust power system that I can pretty much do anything. I think we're really at the point where we're looking at, the next step of adding more solar, getting the wind and the hydro going.
Electrical side, no. I mean, the things you talked about on the property, where things like well pumping, doing that kind of irrigation, which is going to be an additional load draw for you, so you're prepared for that for the future. But, I mean, honestly, you're spoiled. I mean, in the position you're at as a solar installer, right? You get access to some equipment and you have the ability to do the work yourself and the like. I've never seen a home that has 2 setups like you have. You know, the luxury of having one dedicated one for your shop is pretty cool.
And the real benefit for me, we live in on a low yield well. California is still, while we're not out of our drought, really we haven't got a lot of water. And so one of the hardest things living off grid is really air conditioning. And where we are, we hit temperatures in the summertime of 115 degrees. So the next personal step for our house is really putting in a full-blown air conditioning system, like a heat pump of the one that we did on the Governors. It was amazing. It was a 5-ton variable speed soft start, and that is my dream air conditioner. So the Carrier's next. Yeah. And this is going to let us do that. This is going to be the system that we use to run our air conditioning. So this is going to be my my high surge, high production system. Also because I'm going to have more storage capability and I have more production capability because of the inverters. Yeah. And you know, out in the trailer, I still have 2 more inverters. We're going to put 1 more up. This is going to be a true microgrid, in my opinion. It's going to have a ton of power. It's going to be able to run a future shop if I want to do it. There's not really anything that I won't be able to do. I can't wait to do more welding because we have the capability now to really hit those high surges.
Cool. Cool. I have to tell you, I've seen a lot of solar installations, your attention to detail and stuff. I learned a bunch of stuff watching you do the install over the last day. You know, it's really cool. Your work is top notch, really amazing.
Thanks.
And, you know, again, proud to have these batteries in the system at your place. That's great.
It's going to be fun when we go for round 2.
Yeah.
Awesome. Well, thanks.
Thank you.
Awesome.